So let's look at the three runners that we focused on that all started at the fence. Mr. Young looks like he started at the fence. Mr. Vaca started at the fence. And Mr. Houlihan started at the fence. We're going to focus on these three today. We'll look at the other runners who all look like they started off of the fence on sometime next week. So let's start with Mr. Young. So if I wanted to describe what this table is saying verbally is, he started the race at 0 feet ahead of the fence, which means he started at the fence. His speed was increasing 2 feet every second, and I know that because of the relationship between distance and time. He increases 2 feet in 1 second, another 2 feet in 1 second, another 2 feet in 1 second. And I know the graph should be a nice straight line because we learned on Monday that a straight line on a graph means a constant speed. You can see he goes up 2 feet in 1 second, up 2 feet in 1 second, up 2 feet in 1 second. Now, the equation is what I want to focus on today because what's really happening is if he's going 2 feet in 1 second, then if he goes 2 seconds, then it's 2 times 2. If he goes 3 seconds, then it's 2 times 3. So you can find the distance by simply multiplying his speed, which we know is 2, times how long he runs, and that will give us the total distance. So for example, if I say 2 times 0, I know that's 0, because at 0 seconds he's gone 0 feet. That means if I plug in 0 on the x-axis, I get out 0 on the y-axis, and that's that point right there. If I plug in 1 for t, or time, that means he goes 2 feet every second. So in 1 second, that's 2 times 1, or 2. So after 1 second, he's gone 2 feet, and there's 1. If I plug in 1 to this equation, I get out 2. So there's the point 1 comma 2 right there. If he goes for 2 seconds, then 2 times 2 would be 4. And that means if I plug in 2 to this equation, I get out 4. If I plug in 3, I get out 6. So this is important because this can tell me how far he's gone after 10 seconds. So after 10 seconds, he's gone 20 feet. So in 10 seconds, he's gone 20 feet, which would be up here somewhere on the graph. So to write the equation of a table, it allows us to predict the future. It allows us to predict where he will be at any time. So again, how do you write the equation? The first step is you have to find the speed. And the speed is determined by how many feet he increases in how many seconds. So he increases 2 feet in 1 second. You could also say he increases 4 feet in 2 seconds. Or you could say he increases 6 feet in 3 seconds, but all of that simplifies down to 2. So the 2 is the speed. Let's look at Mr. Vaca as another example here. Mr. Vaca, this is his table. So if I was going to describe his race, I would say pretty much the same thing as Mr. Young, except his speed is different. And let's look. What do you think his speed is? Well, it looks like he goes up 3 feet in a second, another 3 feet in a second, another 3 feet in a second. So his speed is 3. He would have the same kind of graph, except it would go up a little faster, because at 1 second, he's already here. At 2 seconds, he's already at 6, and so on. So his still a straight line, but going up a little faster. What do you think his equation would be? Well, it would be very similar, except now he goes 3 feet every second. But how could I figure out how far he goes in 10 seconds? Well, if I want to know the time, I just guess or assume whatever time I want. And I want to know after 10 seconds, so I'm going to say 3. I'm going to say 3, because that's Mr. Vaca's speed, times 10, I know is 30. So that means after 10 seconds, Mr. Vaca has gone 30 feet. So he would be in the lead of Mr. Young, even though they start in the same place, because he has a faster speed, he would be 10 feet ahead of him after 10 seconds. Let's look at Mr. Houlihan. And Mr. Houlihan, again, would be the same verbal description. as Mr. Young and Mr. Vaca. But now, what's his speed? He also starts at 0, but he increases 2.5 every second. So that's a little bit faster than Mr. Young, but not quite as fast as Mr. Vaca. So he would be faster than this line, but not quite as fast as Mr. Vaca's line. And what would his equation look like? Well, his equation would be very similar to Mr. Vaca's, except his would be 2.5 times time, his distance. So for him, it would be 2.5 times 10. And I know 2.5 times 10, everything just gets an extra place value and becomes 25. So after 10 seconds, he'd be at 25 feet. So between the three runners here, after 10 seconds, Mr. Vaca would be in the lead, Mr. Houlihan would be second, and Mr. Young would be third. Don't tell Mr. Young.